Hey, it's Adam. Welcome to Nibbles Tutorial Episode 3, where we create the classic snake game with C++ and SFML. In the last episode, we made our snake move around. It responds to keyboard events and changes direction using a direction cue. We added an apple for the snake to eat, which makes him grow and speed up. In this episode, we'll add some more collision detection for the snake hitting itself. We'll also create some walls and learn how to load in levels from external files. If you have trouble with any of this, or would like to offer support to other people, then please consider joining the community at forums.caf.tech. I do look forward to seeing you there. First thing we'll do in this episode, we will add collision detection with the snake hitting its own body. But first, we need to add some game state so we know to switch the game into game over mode when the snake crashes. So in engine.hpp, we need to add, up under private, add a new int, current game state, and we'll also add last game state. The reason for last game state is we want to actually be able to pause our game, and because we will use a toggle to pause on and off, we could pause in the game over state or we could pause in the running state. So we need to know what the last state was when we unpause. That's where we'll store it. Now, states, like our directions, we use an enum to make it easy. Enumerator, game state, we'll have running, paused, and game over. Spell paused correctly, it'll be easier for everyone. Now, update.cpp, let's look at our collision. After our moves, collision detection, apple. Alright, so after the apple collision detection, we'll do snake body detection. So snake body. We'll iterate over the snake. Now we'll check if the head is running over a section of the snake's own body. So if snake 0, which is the head, get shape, get global bounds, intersects with snake at index S, get shape, get global bounds, game over. Will be brutal, no second chances, game over if you crash. Current game state equals game state, game over. Now we can change the game state to game over, but our game currently just ignores it. So we'll make a change to the run loop. Back at engine.cpp, go down the bottom to where we put our run, and in here, after we get our delta time, before we update the time since last move, we'll go if current game state is equal to game state paused or current game state is equal to game state game over. If we are paused, then check put, so we can unpause, then just continue to the next loop. So we'll always check for input. Now, if we're in game over state, draw the game over screen. We won't actually do much yet with that, but we still want to draw the game. So current game state equals, so if current game state equals game over, run draw. If it's just paused, we won't bother doing the draw. So we're going to run a sleep. 2. I like to sleep in these quick loops so we don't peg the CPU. Because this loop doesn't do much, if we're in game over state, if we're in pause state specifically, all it does is checks for input and then loops around. If we don't put a small sleep in here, then it'll do that loop as fast as it possibly can, and it'll max out one of your CPU cores doing it. So we put a small, just 2 millisecond loop is enough, sleep is enough. And after we sleep, we run a continue, which will continue to the next iteration of our main game loop. It'll skip everything below. So if we're paused or if we're game over, we'll come in here, and then at the end, we'll just start the loop again until one of these states changes. Now, we should be able to test our game and crash our snake into itself and see how the game stops. So I don't think we can actually crash into ourselves when we're 3 long, so let's eat an apple first. Of course, the apple's miles away. Alright, we should be long enough to crash now. Bam, I crashed into myself and the game stopped. So we're in game over state now. We haven't got any way to get out of game over state, so we should think about doing that. First, let's add a way to pause and unpause the game. After that, we can make it so we can restart the game after we die. So engine.hpp, we'll need a new function, call it toggle pause, and then in engine.cpp, let's define our toggle pause. Let's put it here above our run statement. So engine toggle pause. Now this will, if current game state is equal to running, last game state equals current game state. So we save our game state. Current game state equals game state paused. Else if current game state equals paused, so if we're already paused, current game state equals last game state. So just revert it back to what it was doing before. Now, we need some event handler to capture that pause key. We'll put that in our input CPP. We'll do it underneath our quit. Pause, so if event.key.code keyboard pause, we're going to use the pause key on the keyboard. It's the one above the page up key. It'll say pause break normally. And all we want it to do is toggle pause. Now we should be able to test our game, make sure the snake stops moving when we press the pause key and starts again when we unpause it. Alright, snake's moving. I'll press the key. He stops, the whole game pauses, and if I press it again, he unpauses. Now one more check, pause it, put in some direction events. I'll go down, left, and then unpause it. So it captured the cues because it's running the input loop. And it remembers it until the next time the snake moves. Alrighty, cool. Now let's make it so we can restart the game if the snake dies. So what we can do is accept a key press when we die to change the game state back to running. But we also need to reset everything: the snake size, position, the apple location, and later the level and score. Let's make a function to handle doing all of that. Then we can also call that function as we start the game. So in engine.hpp, we'll create a function. Let's call it start the game. I'm sure there's a better name for it, but that'll do us. Over in engine.cpp, we want to define start the game. I want to put it directly under the constructor. Start the game. All right, so what does it need to do? It needs to basically do all this setup stuff. So speed equals 2. Let's move these up here. Time since the last move we'll need to move. Sections to add we'll move. We'll move all of this here. Bam. Bam. So it resets the speed. It sets the snake direction back to pointing to the right. It resets the last move time. It resets sections to add. We also want to clear the direction queue. Direction queue.clear, so it doesn't automatically go off because you've pressed a heap of keys. Calling new snake, calling new move apple. We want to actually set the current game state. Game state running. That's something we weren't doing before, which we should have been doing. And we also need to set last game state equals current game state. So at the start of the game, or when we start a new game, the last game state needs to be set to the current game state. So if we pause and unpause, it knows what to do. Back up here in the constructor, we should call start the game. Now, if we test it, the game should start properly. It'll call this function here and do all the same stuff it was doing before. No errors. Game starts, runs, pauses. It's all good. Now let's do the input for new game. So under pause, new game. So if current game state is equal to game state game over, so if we've crashed, we will check if event.key.code equals keyboard. We'll use the enter key. We'll run start the game. And we'll test again. This time, we'll test crashing the snake to trigger the game over state, and then press enter, should start the game fresh. All right, so as before, we need to eat an apple before we can crash into ourselves because we're not quite long enough. Munch. Apple moved. Let's eat another one. Bam, we crashed into ourselves and the game is over. If we press enter, it should start again. Bam, new snake in the right direction, in the right position, new apple. Speed and length is reset. So that's exactly what we want. Nice. Now we want to add some walls to crash into and to keep us inside the screen. Instead of just hard coding the levels, we will load the level data from text files, so you can add and change the level as you please. We'll keep those in the assets directory. We'll create a directory inside assets, new directory, call it levels. Inside levels, we'll create a new file. We'll call it level1.txt. Now you want to copy the contents of my level file on the GitHub repo. We go Nibbles 3, assets, levels, level 1. And it's easiest, we can just copy it here. Copy. Go back to our level1.txt, paste it in. Now notice it's just a plain text file. It's 40 across by 30 down, and the wall sections are delimited by the letter X. So anywhere there's an X, the game will place a wall section. So later levels will have walls inside the actual arena, and you can make a maze out of walls. We'll also make the game load as many level files as you put in there. So if you want to make the game super hard, put as many level files as you want in there, and it'll load them up. Later, when we add our ability to load the next level, it will just carry on and keep loading levels while you've got them. Now we also need to create a levels.txt. Levels.txt will be a manifest file listing the level files that are available to load. Each line should simply contain the name of a level file. So level1.txt is the first line. So as we add another level, you'll want level2.txt. Right now we'll have one level just to get it up and loaded. Close it, close it. So before we can load in the level, we need to create the wall class so we can add the walls to the screen as we read in the level file. The same way we made the level section, the snake section class and the apple class. So we'll go to headers, go new, class, call it wall. Move our wall source into the source directory. Alrighty, so wall.hpp. What do you think goes in here? Wall will use SFML graphics using namespace SF to save us some time. Class wall. Private. Public. Walls will be made up of rectangle shapes. We'll call it wall shape. Public. We'll create our constructor with a position and a vector2f for size. Now we haven't done the size like this previously, we've just hard coded them all. This time we'll actually allow it to be added on the constructor. And we'll need a get shape. Oops, as a function. Now in the CPP file, do our constructor, wall, so wall shape dot set size, it'll just be 20 pixels for now. wall shape dot set fill color, white walls, wall shape dot set position, right. Now we need get shape so we can draw it. Wall shape. Alrighty, back to our engine header. We're going to need to include our new wall class. Wall. Now, because we're loading files, we'll need to include fstream. Now we need a vector to hold our wall sections. Vector of wall sections. Capitalize that S there. Make sure we're using camel case because it looks nice. We'll want an integer for current level, so we know what level we're on. We'll use that for scoring and also for incrementing the level later on. It'll be handy to know how many levels we actually have, so we can stop loading when we get to the end of them. We'll need a vector of string levels. This will be the names of the level files. And we'll need a couple of functions. So underneath move apple, let's go void check level files. In check level files, it will load in the manifest that we created, and it'll check all of the files that are in the manifest, make sure they exist, and it'll add them to the levels vector. We'll also want to load level. Now engine.cpp. We want to set our max levels to 0 to start with because we have to assume that there's no levels. And we'll run check level files. We'll write our function to check the level files. Let's put it above our run function. Engine check level files. Let's give this one a big comment. Check the levels and make sure that we can open each level file. Add good level file names to the levels vector and increment the max levels. Alright, so load the levels manifest file. So we'll need an if stream levels manifest. It's going to load assets / levels / levels.text. We'll need an if stream test file. We'll use that to test that the files exist. And we use a for loop to go through everything in the manifest file. So for manifest line, get line, levels manifest line. That for loop is a little bit different looking because we don't have an incrementer on the end. Check that we can open the level file. So test file.open assets levels plus manifest line. So the line so manifest line should just be one of the lines from the manifest file, which will just be the name of a level file. So assets levels, and we need to put a slash at the end of that, and then level1.txt, for example. All right, so if test file dot is open, so if we were able to open it, the level file opens. Let's add it to the list of available levels. So levels dot and place back. I'll put a string just pointing straight to the file. Manifest line, bam. We'll close the file, test file dot close, and then max levels will increment. And that's all check levels does. Reads the manifest file, reads each line of the manifest file, checks if it can open the level file. If it can, it adds it to the levels vector and increases the maximum number of levels. Now we need to do load level. Let's put that straight underneath. Let's put a big comment on this one. Load a level from a file and check for X characters to add all sections. Takes a parameter of level number, which is an integer. It's the number of the level to load. Alrighty, so we're going to need a string level file equals levels level number -1. Remember, vector indexes start at 0, and our game will actually start on level 1. So if we're to get the first level in the level files, in the levels vector, we need to go level number -1. So 1 minus 1 equals 0. That's the first one. Level 2 is 2 minus 1 equals 1. 1 will be the second level. Sounds confusing, but you work it out. An IF stream for the level. Load the level file. We'll need a string to hold the line. We're going to read each line of the text file one at a time. So if level.is open, so if we manage to open it, we'll do a couple of for loops to get through this file. We're going to do nested for loops here. So int y, we're going to treat them as x and y coordinates, x along the page and y down the page. Because we're reading across first and then down second, like across and then down 1, across, down 1, across, down 1, we need to put the y on the outside of our nested loop. We know we're getting 30 lines out of y. Get a line from level, put it into the line text string If I spell line correctly, it won't turn red. There we go. You guys saw that, didn't you? For, we'll do our second for loop. Int x equals 0. X is less than 40, so we're going 40 characters across. X plus plus. If line x is equal to character x, then wall sections dot and place back a wall vector 2f. This is the position, x times 20, y times 20, because our wall sections will be 20 wide. Vector 2f, this is the size of our rectangle, 20 by 20. Bam. Now, down here we need to close that level file. Don't leave files open. Closed. Okay, up in the start the game function, we want to set the current level back to level 1. So whenever we restart the game, it'll be on level 1. We want to load level, current level. Now we want to update our move apple. Remember we had that to do? Add check for apple on wall sections. Let's deal with that right now. Check if it is in the walls. So for auto w wall sections, auto is a handy way of letting your compiler just work out what the type of this variable should be based on the class that it's from. So auto, this is a pointer reference, so we're not copying anything, we're just looking at the location of where that wall section is. I use the letter W just as shorthand for wall sections. So each iteration of this will check the next wall section and point W to that wall section, so we can gather the location of it and do things to it. Up here on Snake, I use S. They can be any letter you want. I just keep them relevant. If w.getShape.getGlobalBounds.intersects. Let's put this on a new line. Actually, let's move the whole intersects thing down on a new line. So if it intersects a rectangle of float, same as what we did on the Apple one. Just copy that. So make sure yours looks right. So if w.getShape.getGlobalBounds intersects with a rectangle made of the new Apple location XY of size 20 by 20. So that means if the new Apple location is on a wall section, then set bad location and break out of the wall section loop. Remember, that'll force our move Apple randomizer to try again. Now, before we see any walls on the screen, we need to draw them, don't we? Let's draw walls first. Draw walls. We'll do that for loop. auto and W wall sections window. Hang on, I spelled auto incorrectly. Window dot draw W dot get shape. Bam. Alright, so we should be able to test our game now, and we should be able to see walls around the screen. There they are. There's white walls around the screen. Now we're not checking for collisions yet, so the snake can still go out of the screen and straight through the walls, but we're drawing them. That's cool. It's loaded that from a file and created those sections into solid walls. Now let's do one last thing this episode and make it so our snake dies when it hits a wall. So let's go to update.cpp and set up our wall collision. So you got collision detection snake body. Let's do collision detection wall. So we're going to iterate over those walls again. Auto W wall sections. So if snake 0, so the head of our snake, get shape, get global bounds, intersects. This intersects thing is part of SFML. It's really handy for collision detection. It just checks if two shapes or objects or sprites in SFML are overlapping at all. So if it intersects W, the wall section, dot get shape, dot get global bounds, and it's game over, baby. Set the current game state to game over. Now if we test the game, we should be able to crash into that wall and the game will end, and we'll be able to press enter to start again. Let's try it out. There's our little snaky. Let's crash him. Bam. Game over. He stopped. His head went into the wall and he stopped. But press enter. Whoop, new game. Crash. Game over. I'm going to eat an apple and get a bit longer and crash again. Bam. There you go. That works nicely. This episode, we managed to set up game states, allow the player to pause the game, and handle game over events while allowing the game to be restarted. We are loading a level from a file and building the game walls based on that level file. We're detecting collisions against the snake body as well as the game walls. This brings us closer to a full game. You can play around with it now and it gets progressively more difficult as you keep eating apples. Next episode, we'll start keeping score and we'll have the game load the next level after we eat so many apples. If the next level file exists, of course. Using fonts and writing text to the game screen is a little bit verbose, so we will write a function to make it easier on us. That will about conclude our little game. So the next episode will be the final episode in this series where we'll complete our game and I'll discuss where to go next and offer you some further learning resources. As always, if you're having trouble with anything in this series, then please leave a comment in the comments below this video, or even better, come and join our community at forums.caf.tech. Please consider hitting that subscribe button, and if you can, I would really appreciate your support on Patreon or Ko-fi. Thanks for watching. Stay caffeinated.